Welcome. We're going to talk about some very exciting stuff here. This is the session to learn about the future of VDI.
And who are you?
I'm Daniel Beveridge. I am the senior architect in the Office of CTO for a company called VMware that I work at. And we are going to show you some revolutionary stuff today. Seriously, this is a very exciting set of material. John and I have been working on VDI since 2006 together. That's like the Jurassic period for VDI. And we've been through a lot of design iterations. And I can tell you with confidence that the stuff we're showing this year is certainly for me the most exciting material that we've thus far come up with.
Yeah. And who am I?
This is John Dodge.
Hi, everyone. My name is John Dodge. I'm the Director of End User Computing Technical Enablement. Daniel and I, we go way back, prior companies, lots of collaboration, a few mojitos. Here and there. He introduced me to them, so I don't remember all of them, but it was really good. And so, you know, what I'd like to say is at VMware, there are people who work on defining the vision, defining the future. Daniel here not only defines the future, but he also disrupts it, which is a little bit of, I don't know, a self-serving thing. You can define it and disrupt it at the same time.
As long as I get the cadence right, every 6 months.
That's right. So we do have a disclaimer slide. Has anyone seen this disclaimer slide before? Okay, you might have read it once or twice. Now, in most of the sessions, though, the disclaimer slide is just like vapid. It's just there, yeah, blah, blah, blah. You're not going to tell me anything proprietary, secret, or valuable. In this case, though, there's some really cool forward-looking stuff. So this presentation will definitely contain features under development, well underway. But this is an overview of that technology. There's no commitment from VMware to deliver these things, except I'm pretty darn sure we are, because they are really, really cool things. As with all of future forward-looking statements from VMware, these features are subject to change. So don't run home and buy $6 million worth of VMware by including this in the contract. Just buy $6 million worth of VMware because you love us, if that's all right. So anyway, let's take it off. Anyway, one other thing. Has anybody seen the survey slide before? Most of you haven't. You diehards who hang around to the very end, to the very last slide, you get to see the survey slide. But we really care about your feedback. We read the surveys. The scores do matter. The scores are used year over year to rate good VMworld presenters. If you like what Daniel and I do for you up here on stage, the surveys really help. The comments are also very entertaining, so please put some comments in there. We do respond well to feedback.
We already have a question.
A question, yes, on the survey.
Last year asking your sessions to be moved from Thursday earlier.
Yes. More like earlier Thursday morning, 7 a.m., meet you for breakfast? Earlier in the week. Well, we did have a session yesterday. And part of it, part of the challenge with where we were in the schedule was that Daniel is such a draw, and he needs me to balance and now bring his numbers down. And so we had to get moved around. We had a much larger session. We got split up and moved around and whatnot. So thanks for the feedback. Put it in the survey. Maybe I'll ignore it again, and we'll see you next year, and you can bring it up again.
They may just replace the keynote next year.
You know. I'd love to do a keynote with.
So today we're going to talk about what we call the new desktop opportunity, new design ideas around VDI that have become possible recently with a collection of new technologies. We're going to cover some VMware Virtual SAN innovations, future directions in vSAN technology. We're going to talk, of course, about our layering. That's related to our Cloud Volumes acquisition. How many folks saw that on stage? Pretty awesome stuff, or what?
Excited about it? Can I hear a little of that excitement? We thrive off of it. All right. Very cool.
Good stuff. So we're going to also talk about rapid provisioning. That's the Project Fargo that you may have heard about. That's some really science fiction-y sort of stuff we're coming up with. And we're going to also bring it back together with hardware and software working together, and also simplifying VDI. So at the end of the day, VDI admins want to deploy it easier, less barriers to adoption, less of the complexity in the design cycle that certainly John and I have labored through in several consulting companies before we came here, seeing how sometimes challenging it can be for customers. So we're going to talk about why that's about to change.
So I thought I might walk you through setting the stage, we like to talk in terms of VDI 1.0, 2.0, and next generation. So looking back to VDI 1.0, we were really grappling with some really difficult challenges. The first challenge, the first load of bricks piling down on the IT admin's head and shoulders was storage costs and performance. And in fact, it was too costly, and there was a very inconsistent user experience. As a matter of fact, that inconsistent user experience would come at the least convenient time of the day. That is when users wanted to work. It's as if there's no traffic on the highways until you're trying to get to where you're going. And you're just nothing, everywhere you try to go, you're always in traffic, and yet by the time you get where you're going, you look and there's no one on the roads at all. And that's what poor storage design and innovation looked like. Couldn't keep up with the user demand, and when the users most needed a snappy experience, they weren't getting it. Very, very frustrating. The next thing was the advent of 3D graphics. Now, for a while, we were able to tell people, hey, stop using Aero. There's no business use case for Aero. However, now we are seeing some really fantastic applications that legitimately make use of OpenGL and other 3D technologies. Particularly if you're in oil and gas or manufacturing, you absolutely need these capabilities. And VDI is definitely able to get there. However, what we found is VDI 1.0 was really lagging behind the PC experience in that respect. The next thing was application management. Application management forever has been no user-installed application support. It has forced image diversity issues upon us, and there's always the issue of performance. I don't know if anyone's had the opportunity to talk to Harry Labana, who came over with the Cloud Volumes acquisition. Once upon a time, he was at a very large Wall Street firm running IT of his own, and a staff of about 150, 200 IT staff. He once polled and said, how many people do I have managing applications? What do you suppose that percentage would be? Anyone have a guess? Percentage of IT managing applications? 20%? 60%? Well, he said he found about 40% of his staff was dedicated to keeping applications up to date and deployed, and he never had it right. He never had a sense that he could sleep well at night. So that's a big problem that needs to be solved.
And one thing on that as well is, with the stateless designs of VDI 1.0, people leaned on things like app virtualization for app delivery, and you ended up with a lot of complexity around packaging applications in order to get them to personalize the VDI, and that wasn't always very easy.
No, and did you know anyone personally who recommended application virtualization to customers?
There was a guy, guy Daniel.
Out of Jersey?
Yeah, that guy.
And a guy with him, right? I think
Dodge.
Right, Dodge.
That's right.
So Daniel and I, we were there recommending all these alternative technologies, and they weren't all that alternative, and they were.
At the time, they were the only options.
They were the only options. The only way that we could improve one side of the equation by shifting some of the burden to the opposite side of the equation. And in 1.0, VDI 1.0, we've been grappling with provisioning, and really two aspects here. It's slow provisioning and long pool maintenance operations. I remember for the longest time a 2,000 desktop pool VDI maintenance operation. We were happy when it was done in 8 hours. And we've got some users and customers, they were happy if it was done in 8 hours. And in some cases, because of lagging storage performance, it wasn't 8 hours, it was 10, it was 16.
It was even longer.
Way too long.
And one of the things that made that worse was we were trying to save storage for people using linked clones. Great idea, right? Storage is expensive. So people used even less hard drives because they had saved on the space. Now you have less spindles, less IOPS, and that sometimes lengthened the process.
Absolutely. And so what does all this mean for IT? Well, it's a very frustrating experience. That frustrating experience is felt everywhere. This is both the IT admin and the users who are victims of VDI 1.0. By the way, they're victims that we helped bring that reality to their universe. Although it was frustrating days, in a lot of cases, the solutions were still way better. And so now here we come with the next generation VDI. We've got a lot of really exciting things. Now, it's not exactly a shock that the things that I pointed out as problem statements are things that Daniel are going to outline for you in terms of what we're bringing.
Well, that was VDI 1.0.
We're going to need another mic. We need mic 2.0.
I'm cloning my mic right now.
So, I've outlined the challenges of VDI 1.0 that we are very aggressively addressing in next generation VDI. I'm just going to kind of get us started here. We've got the efficient use of architecture, of infrastructure that we're going to be bringing, and something that we're really excited to call what, Daniel?
Just-in-time desktop. This is, think of just-in-time manufacturing. When you don't need to build something ahead of demand, you're building it at the point of demand. And what's the big benefit there? You get to avoid creating a whole inventory of useless virtual machines sitting around just in case someone needs them. So just-in-time desktop is basically a build-on-demand idea. And one of the ways we're achieving that is a new type of architecture called zero-copy architecture. We'll be talking more about that.
So we're transitioning away from just-in-case to just-in-time. Just want to make sure.
That's right, just-in-case to just-in-time. Very good, John.
Thank you.
So
I get paid for that kind of stuff.
Very nice. The goal is the leanest, greenest desktop that we can produce. It's not enough just to virtualize desktops in the data center anymore, as incredible as that was 5 years ago. The goal now is to do that with the least work possible. We don't want so much crazy bit streams and CPU cycles and I/O storms happening in order to accomplish basic provisioning tasks like pool creation. So the just-in-time desktop avoids a lot of that. We also want to give users more flexibility. In VDI 1.0, you had this impossible choice between an affordable VDI desktop based on stateless architecture or a very flexible desktop based on full clones where you could use your existing management framework, your PCLM tools, but you suffered a high cost. So you had to choose between those two. In the next generation VDI, we're going to get beyond that. We're going to give you both of those things. You're not going to have to compromise. As John said, user experience is critical. In fact, I kind of blame Apple for this. They came up with these iPad things, and suddenly people expect everything to be snappy and
Anyone have this
flash-based.
experience? Buy an iPad, and all of a sudden you want things to be snappy?
They claim their PCs are just not keeping up. So, things with spindles and high latency or erratic user experience, they may have been something you could inflict on your users with impunity a few years back. But now, users just really won't tolerate it. They're much more savvy to a good user experience. And so it's important, it's critical even, that VDI in the next generation of design gives users a very delightful experience, very snappy. And for that reason, we'll be looking at some advanced flash technologies that help accomplish that around vSAN. And lastly, John, why don't you talk about simplification? That's something you have a lot of data points from in the Lighthouse.
You want the simple mind to talk about simplification?
If you can handle it.
I don't know. Maybe I got to sit. What we're looking at here is that VDI 1.0 is really, really complicated. In fact, back in 2006, Daniel and I were pitching to a very large Wall Street bank this idea of VDI, and I think it was 8 or 9 different vendors kind of being integrated together. What we're really looking for are adaptive designs, these designs that, you've got one architecture that accommodates virtually everything that you need to apply, and without PhDs required to put it all together and PhDs to operate it. We like to call that decision-free VDI. Desktops without all the catch-22s or the trade-offs of, the agonizing need of the users contrasted to the requirements that we need in infrastructure to deliver it.
Exactly. So that captures what we think is the right focus for VDI going forward. So some of the solutions that are going to contribute to realizing that, we're going to talk about vSAN. vSAN is our amazing software-defined storage solution. It allows you to converge compute and storage on the same fabric. It allows you to build your storage capability out incrementally. Horizontally, as you expand your cluster, you get more I/O. And you don't have to design with those torturous spreadsheets, sizing exercises. I really hate those. And I had to do a bunch of them when John and I were working together. The reason is because you're buying a fixed thing, an array, and you have to decide how much to buy. You don't want to buy too much, because you drive the cost down.
Too expensive.
You don't buy too little, but you don't even really know the onboarding rate of the VDI users. What if they grow a design faster than you think?
And then you get a bad user experience.
Or they grow it too slow, and they're sitting on top of $1 million array that they're not using. So with vSAN, you can get away from that. You just design what's right for a single host. So however many users you want to design or support for that host, that's your design target. And once you get that right, you can just copy that, clone it out more or less as you expand your cluster. So much simpler. 3D graphics, John talked about that. We've already made some advances, and you're going to see more advances next year. Sharing hardware efficiently, getting a raw GPU experience, and yet sharing the hardware GPU across multiple users. Look for that.
I believe that's already in vSphere Beta 1, as a matter of fact. Very exciting innovations there.
Exactly. So we're going to continue to work and improve that. We've also got the offload cards for TeraDG for PC over IP, which improve the user experience as well. Application management, we've talked about that. We're going to get a little more into the department installed apps, user installed apps, things that we just couldn't offer before that is now possible with our Cloud Volumes acquisition. And of course, my favorite, hot cloning, Project Fargo. I'm going to talk about that. So John, what is the new desktop opportunity here that comes out of all these things?
Glad you asked. Not scripted at all. You know, what we see is that VMware View, or I should say VMware Horizon with View, is really poised to disrupt the assumptions that we have about VDI. When we talk about VDI, we're really talking about VDI 1.0, which we've helped bring to the world and to a lot of customers. It's simple to deploy. Low cost is better, so we're looking at better than a PC experience for the same or lower cost. User experience has just become a real priority for us at VMware and end user computing, because we know we're competing with Ultrabooks with SSD drives, we're competing with tablets. In fact, users are using tablets to get to their desktops, and so they already have this going in experience and expectation. We also want to make sure that this is easier than ever to manage. We want to be easier than PC lifecycle management, which is really atrocious. And again, to talk about management PhDs, PCLM has required a lot of expertise. We think it's not necessary. We want to have a flexible operational model. In other words, you know, you don't have to have so many bifurcated sections of your infrastructure to do all these things. Simplified access, administration. We also want to build virtual machines on demand. We've been talking about this for a really long time. That gives us a lot of flexibility at runtime, a lot of flexibility in approaching new use cases on the fly, even operationalizing on the fly, which is kind of interesting. So we've mentioned this a couple of times. The key technology enablers for that is VMware Virtual SAN, or vSAN as we're going to refer to it as. There's layering. You heard all about Cloud Volumes, but you know, we also have layering with Mirage. And we're going to be talking about dynamic application injection, which is a very cool new phrase we're excited about. And we've teased Project Fargo a couple of times. This is the instant cloning of virtual machines in under 5 seconds. That gives us that just-in-time desktop technology. We're going to get a lot further into Project Fargo as we go.
Sounds good. So let's first dig into VMware Virtual SAN. So this really is a revolution. I've sort of hinted at some of the challenges with traditional array architecture. It's a guessing game when you launch the VDI deployment, how much to buy, how fast to roll that out, and what sorts of media you need. Very difficult IOPS calculations. And wouldn't it be great if you could just get away from all that and have that be a very minor part of your engineering effort? So vSAN gives us that. So we have reliable, scalable performance. Scalability comes because the bigger your cluster, you inherently get more I/O. Every host contributes, let's say, 10 or 20,000 IOPS based on its SSD capabilities or more. And as you grow the cluster in response to user demand, you grow your storage fabric in lockstep. So you get away from that conundrum to buy before or later. We have the lowest cost in the industry. We're driving that cost down further. The reason vSAN is so inexpensive is you're not paying a lot of proprietary sort of perhaps hardware fees on high-end arrays, but you are buying a combination of flash and hard drives that keeps the cost of media fairly low. And you've also got a very nicely integrated solution with the vSphere platform. So planning is easy. Uptime, we have good uptime with vSAN. You can even do maintenance on a host, take it down for an upgrade, a patch cycle, and any data that's on that host will be replicated somewhere else on the vSAN cluster so that your users continue to operate transparently. Perhaps the biggest benefit for VDI admins is autonomy. How many opportunities have we worked on together, John, where the VDI admins complain about how long it takes the storage team to be responsive to LUN provisioning, and how inflexible and brittle they are with the sizes and costs that they offer?
About 217.
That's right, about 217.
Maybe 218.
So it's really almost a stereotype.
Has anyone run into that before? You get the storage team invested in a decision you wish they kind of weren't? Anyone had to deal with that? You know, you can't keep blackmailing the storage admins. That kind of gets old after a while, you know. So what we want to be able to do is to bring that autonomy to the VDI architects. Let them make the right choices, because the storage guys, they usually don't take the time to understand VDI, and what do we get? We get the wrong matched storage in that equation.
Yeah, I once was working with a large financial company that only sold 300 gig LANs, and they were 12,000 euros per LAN charged back internally. Now, it didn't cost them that much on the media, but they're inflating it to cover their skills.
That's right.
The priesthood of storage admins. And so as a result, the
Sounds like a motorcycle club.
Exactly. The VDI effort was completely grounded because no one wanted to consume VDI internally because it was just completely too expensive.
That's right.
So vSAN solves those sorts of problems. We also have a great policy-based management framework. So what does this mean? Most storage is based on blocks and LUNs. vSAN's different. It's object-based storage. It's based on VMDKs. So actually, that's the object we're storing, and we can attach different sorts of performance and replication policies at the VMDK level. So imagine you have a virtual desktop that's comprised of several different virtual disks. And we'll get into why that might be a good idea in a few moments. But vSAN will allow you to have a different replication policy for the OS disk, the C drive, versus a secondary disk where you might store your user data. So you might have two replicas or three of your data and only one of your OS disk, because it's very easy to replace. There's nothing really unique about it. So
we don't have to manage this on a per VM basis. We can set the policy once and
you can
let
set the
vSAN
policy
take
on the
care of it
template,
for us.
and all the children that you clone out could have that same policy. And why would you do that? Because you want to reduce the consumption of media. You don't want to overprotect data that's not very valuable.
You don't want to over-rotate on management. So what's the big picture?
The big picture is this is the go-to storage for VDI. vSAN is not only revolutionary, but it so simplifies the process of provisioning that it's definitely going to be the go-to solution.
Were you going to ask our friends here a question?
I was going to ask them if the term over-rotate has been overused.
Has it been over-rotated upon?
You're
I don't know. Quick show of hands, how many times you've heard the term over-rotate? And are you done hearing it? No, see, it's still good.
All right.
I think it's still
Keep
viable.
using it.
It's viral. There's some dissent among the ranks, but it's just one guy.
So we've got some special design goals here for VDI with vSAN. We want to protect only what matters. There is this thinking in storage that storage is all about data protection. But in fact, storage serves many purposes. You could just really need some scratch space, some execution space, and you don't need to protect it. So the role of storage is not always to mirror or to have a very conservative posture with data. You need to think carefully what you're protecting and how much you need to protect it. And vSAN gives you those options. So in the designs we're talking about, we're thinking a little bit more granularly about what we want to mirror and what we want to have single copy on top of vSAN. So a good
now
example.
Specifically, I think we're talking about the multiple copies within vSAN. So
Absolutely.
do we want one copy on one host, or do we want multiple copies on different hosts? Is that right?
Exactly. So you have mirroring in vSAN across hosts, but do you really need that? Because it's going to double your media cost, and it's going to potentially even have a modest performance impact as opposed to a single copy. So layering, interestingly, and that's our cloud volumes technology, is a technology that allows us to split up the virtual desktop and yet seamlessly merge it back together from the OS's perspective. So it looks like a single C drive to the operating system and to the user. But underneath, we could be spanning that across 2 or 3 different VMDKs. And those VMDKs could have, in principle, different vSAN mirroring policies. So here's some examples. The operating system disk itself could be a link clone. And we know that we can replace those very easily. That's not really data that you need to protect. It's just data you need to work with. So we may choose to have one copy there. In contrast, you might have a user state disk where you have your user installed applications. And that may be mirrored, because that's the only copy, and we don't want users to lose that data. So we could have a blend there. Now let's think about user documents. We could store them twice, or we might want to use an enterprise file sync system where we already have a copy in the cloud. As soon as you save it, it gets synchronized up, whether it's Dropbox or Secure Content Locker from AirWatch. In that case, maybe you just need a cache. Maybe you need a local cache on vSAN. You need a single copy for rapid execution, fast commits, but as soon as you save it, it's mirrored up to the cloud instead of mirrored on vSAN.
Right.
So it's good to think through these things, and the big point here is that vSAN gives you the opportunity to use object-based policies to accomplish some of these fine-grained designs.
And I also think this gives us an opportunity to take advantage of newer flash technologies. Like our friends from Diablo Technologies are out here, our friends from SanDisk are out here. And there's this really cool technology. I hope you'll have a chance to check it out. It's called an UltraDIMM. It's flash on RAM. I think it's the most amazing thing I've heard since vMotion, to be honest. I never really thought about using the memory bus as a peripheral bus, and yet that's exactly what we're doing here. Or
exactly.
We're not doing it, we're taking advantage of it. The idea is to put storage inside the memory bus. It's not just for RAM anymore. Looks like a little flash disk. Incredibly great performance, low latency. It's really, really cool technology. So I hope you had a chance to see them at the Solution Expo, and if not, I hope you'll take the time to investigate them.
It's part of a macro industry trend to bring the persistence layer closer to the CPU. You know, in the old days, it was out on some bus somewhere, maybe in a different room, and over time, we're just slowly bringing that back to closer and closer to the CPU. Has to do with that speed of light thing, I think.
Yeah, that's pretty fast, I hear.
So UltraDIMMs are actually very cool. You get 3 to 5 microsecond commits into hardware, and we're leveraging some of that speed with vSAN, advanced vSAN designs. So we talked about different use cases. There's persistence, there's full clones in the data center. We still accommodate that, we support that. vSAN is the cheapest way to do that because it takes a lot of space, and vSAN offers the lowest cost per gigabyte. In this kind of design, yeah, you could just manage your machines exactly like PCs in the data center. And that's appealing to some companies. I'm not a big fan of that design, but for some companies, that's what they want to do. vSAN is still a good fit.
And that was the point. We wanted to have the most flexibility for the greatest number of options.
Right. I call that old school. I don't think it's the future, but certainly as we transition to more advanced designs, we want to give customers choice.
Maybe old school will come back again in 20 years.
Like vinyl?
That's right, like vinyl, like hush puppies.
Always good. So non-persistent task worker is a sort of a second design. That's a VDI 1.0 design as well. Here you don't give users much flexibility to persist state. You don't allow them to install their own apps. It's based on View Composer. So you don't store as much data. You have a link clone. That can be on vSAN. That doesn't take up much space at all. But it doesn't have much flexibility. But we support that too. It's a good fit for vSAN. And in fact, those users, because they don't store any state, you could even just have one copy of their link clone of vSAN. You could choose a replication policy of one.
Absolutely. We spent a lot of time helping customers implement those designs over the last 2 or 3 years.
Absolutely. They're still popular. And there's still a lot of task worker use cases out there. Again, vSAN's a good fit there as well. But as we get to more advanced users, power users, knowledge workers, we need something more flexible. But we don't want the cost of that full PC in the data center. So we've got a new design. We're calling it the non-persistent knowledge worker design. And this is a new non-persistent design. It involves layering and vSAN, vSAN's policy-based replication. In this kind of design, the user state is all mapped down to a discrete VMDK by Cloud Volumes. So Cloud Volumes has technology that allows you to filter down to a separate VMDK if a user installs their own app. Instead of hitting the C drive, it looks like it's on the C drive, but it's actually been shuffled down essentially to a separate VMDK. And that's what we call the user disk. Now, Cloud Volumes allows you to move that user disk around and attach it to different VMs on the fly. So if I log into one VM today, it'll bolt it on, and then tomorrow, it'll put it to another VM. So we need 2 copies of that. We don't need 2 copies of the OS disk. The profile disk, UIA, and docs, we should have 2 copies of those unless you're using file sync.
Absolutely.
That gives you some ideas of the designs. So persistent VMs, like we said, they've got some benefits. They've got some drawbacks. They're hard to do DR on. They're heavy on infrastructure consumption. And they're harder to manage because you're not able to achieve one-to-many management as easily as you can with the sort of image composer-based designs.
That's right.
So
it's easy to implement.
It's easy to implement, your flexibility, but you pay for it later along the life cycle of the VDI desktop. You basically pay for it in heavier infrastructure tax and harder management. So the big summary is, while you can do it, it's not the best design for longer term. So, John, why don't you talk about the new non-persistent designs?
Yeah, absolutely. So again, basic non-persistent is VDI 1.0. It doesn't preserve user state. There's no support for user-installed applications or a user profile, and therefore you need a persona solution to go along with it. Advanced non-persistent is what we're talking about in terms of the next-gen non-persistent, which is a persistent experience using layering technology. We have the user state preserved. It goes to a separate user disk, which is mounted just in time at logon. There's the efficiency of the non-persistent with the features of the persistent. And I think that's the real selling point here. So it looks persistent to the user. However, we have all of the new technology. And you notice Daniel's trying to rush me ahead here a little bit. What we're really trying to convey here is that advanced non-persistent is the new persistent VDI. I think orange is the new black, and advanced non-persistent is the new persistent VDI.
Exactly, except that it's green.
You're right, it is green.
So it's really, can't be understated what an advance this is. The new non-persistent design is really a radical leap forward for VDI. In talking about vSAN futures, vSAN itself is evolving. In the first version, it supported officially a hybrid between SSDs and HDDs in the data layer. What's coming in the future, we will be supporting all flash configurations. These will be designs that combine perhaps 2 tiers of flash, a small amount of premium flash, which can cover your writes and where the endurance will happen. And then a large amount of very low-cost flash on the data tier, from which you'll be able to get low-latency reads, but you won't write to that directly. All the heavy writes and the write cache will happen at the top layer. Exactly.
Right, churn.
So you'll be able to use 2 grades of flash, one with high endurance and one with much lower endurance characteristics, even what you might think of as consumer-grade flash, or TLC SSDs, if you're familiar with that term, in that data tier. These are SSDs that are terabyte size or more, and they have a cost that's 40, 50 cents a gig, really, which is on par with today's SAS drives, and the 10K SAS drives are priced about the same. So imagine combining that sort of flash in the data tier with a very high-grade flash, perhaps SLC or even the ultra-DIMM technology from Diablo and SanDisk, could be used in that cache tier, the heavy writes. Now you've got a solution that's all flash. It's performing intelligent triage between 2 grades of flash, and the vSAN software stack is really performing that intelligence on which flash to use for what purpose. So key technologies there, I think, are the new SanDisk UltraDIMM. The reason I like that is because it's moving flash closer to the CPU. You're getting about an order of magnitude better latency than you can get on PCI bus. PCI was great. It opened up a lot more bandwidth, but you still got bottleneck at the PCI card itself and at the controller, and depending how the hardware is architected, the south bridge. In the case of memory channel storage, the memory bus has deterministic latencies in the nanosecond range. And so if you can commit the write across the memory bus to flash, which has got a little capacitor or battery backup, just in case it goes down, you can get a lot better.
Can you summarize this for me? It's a little hard to follow.
So in summary, we've got fast stuff happening.
Fast stuff happening.
Yeah, that's it.
Mechanical hard drives are not really viable for VDI going forward, not with the technologies that we have at our disposal, and they're really pretty inexpensive when you consider cost and performance.
It's true, exactly. So that's the future of vSAN. I like these build diagrams. So here you can see we've got hard drives, we've got an evolution going to PCI that was really the next way to get access to flash more quickly. You put it on a faster bus, dispense with SATA and SAS. But that's not good enough. We want to move it even closer to our high-speed CPUs. Now we're putting it in the memory channel. And at Flash Memory Summit a couple weeks ago, there was even a new technology called nano commit that was introduced. And here you can actually commit the write in the L2 cache of the CPU, which is battery backed up. And that will then destage, even on power loss, to the flash DIMM, which has its own capacitor. And in that sort of design, you can get nanosecond commits. So that's what
pretty
the future
fast.
looks like. Certainly faster than SATA, I think. So we've got a couple of graphs with lots of lines and circles here.
Yeah, we did some research, and we found that the most highly rated VMworld presentations make use of bar graphs, circles, and arrows.
You need a more powerful laser. So anyway,
And
what you're
lasers.
looking at here is we did some view planner testing comparing PCI and ultra-dim technology. And what we found was we get both lower average performance, but we also get, on the bottom, you'll notice standard deviation. That's how much variation there is in task completion. We used our tool called View Planner, which is a knowledge worker simulator. And as we did a bunch of different tasks, office tasks, we timed them. But we also timed the variation, or calculated the variation. And what we noticed by having a lower latency technology, bringing the flash closer to the CPU, even under the highest stress levels, we got very little variation on the ultra-dim technology. You see that in the low blue, right here, those low blue numbers compared to here. This is PCI introducing more variation, because there's more sources of variation in the PCI bus inherently than on the memory bus. So just to give you an example of how the coming flash technologies will continue to improve the user experience that vSAN can deliver. So John, why don't you talk to us about this cloud volume stuff?
Yeah, very good. So I wanted to take just a couple minutes and talk about layering. In fact, we'll just call this Layering 101. I think layering is a concept that's been around a while now. We hear about lots of different definitions, and so I like to take the time to discuss definitions when the definitions really mean something. So first of all, the definition of a layer is a set of OS or application content that can be inserted into a desktop bypassing the normal Windows installation process or mechanism. Now, we really think of this in terms of two different kinds of layering technology. There's offline composition, which is what we leverage in Mirage, and so we work outside of the desktop itself. We inject our changes there. We stream bits to an image. When the bits are all there, we have a reboot, and that's when we compose the desktop during that pivot operation. And then there's the real-time composition, which is what's featured in cloud volumes. Now, offline composition has the deepest compatibility and is probably most appropriate for PCs and laptops. And that's because we can have a mixture of online-offline scenarios there. If there's an update that has to be pushed, so long as the user is attached to the network and get back to the Mirage servers, the bits are coming down. When the bits finally stream all the way down to the desktop, then they can be applied on the next reboot. That's not always the best approach when you're always connected. When you're always connected, now you can apply real-time composition. Did anybody catch Kit's presentation on day 2? You see how fast he was able to inject those applications in there? That's real-time, leveraging vSphere's VMDK mounts for nearly instant application insertion. It's a very efficient use of the data center resources. There's no copies or transfers of data until the point of consumption, meaning that the user has double-clicked a file, and now that application, those bits are required. And they're just pulling in from a Cloud Volumes VMDK, and it launches.
Instead of streaming ahead of time in case you go offline, we know in the data center you're never going offline. We've got tons of bandwidth, so we don't need to use techniques to limit bandwidth like Mirage does.
That's right.
Rather, we would like to limit CPU and I/O in the data center because that's a critical shared resource.
And time. We don't want to wait for the time for the bits to come down. We want
Exactly.
them down right now. So different solutions for different challenges, different layers for different flavors. So on the physical side, that's for Mirage primarily. For the VDI side, that's the cloud volumes for VDI. Now, here's just a little illustration. I don't know, has anyone seen this slide recently? I know it's got a lot of use.
I saw it on the subway, actually.
On a subway?
Yeah, it was on the BART when I came down.
On a sandwich?
It's gone viral. It's in the subway.
Very good. Somebody better catch it, hunt it down, and kill it. This is hypervisor content delivery, and basically there's kind of a before and after here. On the left is the traditional virtual machine with some data and files and applications. These are inside the virtual machine. They're actually in the operating system on that VM's VMDK. And of course,
They're tattooed.
They're tattooed.
That's
right.
a technical term.
Right. And so now we see a new way of doing this with cloud volumes. With cloud volumes, we're able to do a VMDK mount that creates content accessibility combined with a file system registry filter driver that creates the accessibility to the operating system. The operating system doesn't realize that cloud volumes are not actually a part of the system disk or OS volume. So they are injected in dynamically in real time. What's really cool about that is that you can make changes on the fly and they just appear.
So how many know what a VMDK mount is? It's kind of geek speak, but at least a quarter of the room. So to just elaborate a little bit, you can think of it as a giant USB drive that you might plug into your PC. You might have 2 terabytes of data on there. You immediately see it available as a drive, but you didn't actually copy all that data off the USB. It only comes in when you access a file or something. So VMDK mount is the hypervisor. Think of that as injecting a big drive, hooking it up, attaching it live to a VM. And once it's there, the Cloud Volumes agent can essentially merge that material in as though it were on the C drive, even though it's not.
And now I'm going to have nightmares about giant USB drives. We think that there's some really key benefits with respect to Cloud Volumes. There's the live delivery of applications. It's the opportunity to solve the image diversity problem. We can have fewer images because we've got more flexibility through the application. Fewer pools.
Exactly.
That's also very, very important. Really, the idea is to get the exponential infrastructure efficiency. It's one-to-many application delivery, kind of like multicast for applications. This really is virtualizing the work of application delivery. I think it's a very powerful concept for us here. Daniel, why don't you walk us through really quickly, because we got to keep an eye on time here.
Sure, absolutely. So this is what a Cloud Volumes-based VDI pool would look like going forward. On the left, we have a bunch of app stacks. That's the jargon that we use in Cloud Volumes for VMDKs that contain one or more applications. In the top, you have your pool of generic virtual machines that have perhaps no applications installed, just your basic operating system. And then on the right, you have this notion of a user volume or a user-writable disk. This is where you store your stuff. This is your documents, your profile, and even user-installed apps. So when you come in and we want to give you a new machine, we grab one from the pool up top. We map in some app stacks from the left. Those are mounted live at the point you log into the VM. Now keep in mind that these VMDKs on the left, we can mount to more than one VM at a time because they're read-only. So you can mount these to 100 VMs at once. So you just pick one. It could already be mounted to 20 VMs. We're going to mount it to one more. And then on the right, we're going to go select your particular user state disk, bolt it on, and the Cloud Volumes technology will merge all that together to make it look like it's all on the C drive. And your apps will be all installed. It's very quick. It takes a couple seconds. Follow-on users, of course, may get a different mapping of app stacks and their own user-writable disks.
Right, but generally we'd have one user-writable disk per user, but potentially multiple app stacks per user.
Absolutely. Well, the app stacks is a shared catalog. And there's a map to users, and then the user-writable disk that's one-to-one. We've got a great little video here just demonstrating how cool this stuff is. So here's on the left a desktop with Cloud Volumes. You see that there's some documents that they have no viewers attached. So the user tries to launch them, nothing happens because there's no application to handle that document type. Over in the Cloud Volumes management console, we go in and we say, you know what, we're going to give this user the Office suite. So we assign the Office suite to that user, CV user. We say, you know what, let's attach it immediately. We don't even need to wait till they log out. And that app stack has a whole bunch of applications. You can see it's here. It's got a whole bunch of Office applications. So as soon as that's assigned, you can see that it will get attached instantly. So you see PowerPoint and Word is now there. The document that was on the desktop actually immediately changed because Windows recognized that there was an application installed, and you can launch PowerPoint and Word immediately. There's no streaming, there's no copying. We instantly represented that application and launched it. So that's how fast app delivery is with Cloud Volumes. Just 1 minute, we'll take questions at the end. So Project Fargo, this is perhaps what I'm most excited about. This is a revolution in the way we build VMs. In the past, we had to construct a VM from scratch from a template. It could be a link clone, but you always had to copy the bits on the storage array and boot it up. And that's how we've been building VMs for years.
There's a little edit there I'm going to make here. This is Project Fargo. Just going to fix that really quick.
So Project Fargo essentially uses a new technology in the hypervisor, which is called hot cloning. Now, what is it? So basically, we boot up a VM, and we freeze it at a certain point that we want to clone it. And what happens when we freeze it is it stays in the RAM of the hypervisor in ESX, but it stops running. So we don't schedule it on the CPU anymore. So all the memory pages are in RAM, but it's no longer running. It's sort of like a zombie. I call it a zombie. I think you're supposed to use the term live template. I still like zombie, though.
Zombies are good.
So then we want to make a child of the zombie. And so what we do is essentially we create a new VM definition, we register it in Virtual Center, and all the memory pages initially are pointers to the copy that's already in memory. Just like transparent page sharing in ESX, we'll find duplicate pages and replace the second, third, fourth copies with pointers. Project Fargo does the same thing, but preemptively. So every page is initially a pointer. We start the VM, it starts executing, and as it writes its own memory pages, it makes unique copies. So you end up with a whole bunch of shared memory pages and a gradually growing set of unique memory pages.
If I understand right, you're saying that forking zombies create child VMs.
So, yes, technically that's true. But they use less CPU and I/O in the process.
It's a very efficient forking.
Very efficient forking. And once you get forking to a new efficient level, you produce more replicas.
That's right.
That's what
So you'd fork more than once in any given day.
Possibly, if you have the resources. So Project Fargo...
To support the desktops after they've been forked.
We shouldn't go any further with this. So Project Fargo is really revolutionary because instead of booting up a VM, you actually are just spawning it on the fly. So you avoid the whole boot cycle, all the CPU and I/O that you would normally associate with creating a clone, booting it up. That's all eliminated. So the normal process that we would go through with Composer would be to clone, to power on, run our customization script, which takes about 6 minutes, and then you would have a VDI machine ready to use. In the new process, we fork the zombie, and we are ready to roll almost immediately.
That's right. That's a very substantial improvement over VDI.
That's because it's a fast zombie.
It's a very fast forking process.
So just to give you an idea how much more efficient this is, on this graph here you see the old process with View Composer as it is today. We're creating 500 VMs, and you can see that it takes 3.5 hours to complete. Whereas the new Fargo-based process where we perform this forking process, we actually complete all 500 in less than 15 minutes. So think about creating a pool of 500 VMs, 15 minutes, you're done, you're ready. I know that Ty likes that because he's been creating a lot of pools recently for testing.
That's very good.
That's
very
fast. That's the
14
exciting
VMs.
takeaway. So this is the idea of the efficiency. So where does this go? We've got layering, instant app delivery. We've got rapid zombie creation with Project Fargo. And this all leads to what we're calling the just-in-time desktop revolution. John, why don't you tell us a little bit more about where this leads from your standpoint?
Sounds like a Nintendo game, the just-in-time desktop revolution. Here's where we're going. This is a build-to-order desktop, a build-to-order VDI. You get to build your VDI desktop, your VDI VM, when you log into the broker. That desktop wasn't created in advance and is just sitting around waiting for you, ready to do work. It's created on the fly as you're logging in. A lot of capability that we can inject in the process at the time that we're doing it. It's customized for you. That VM is not a generic VM that we fork at the time of brokering. We create that desktop. It's customized for you. And the provisioning is done in real time. Today in the VDI 1.0 world and how we're doing it in View Composer, we're composing these desktops ahead and maybe we're suspending them, but they are ready to go. That's because we have to front load the process because of the time. Project Fargo lowers the time, makes it almost irrelevant in the equation. We can do it just in time as the user's logging in. It only takes a few seconds. The users don't really know about it. There's a lot of benefits to this approach. There's very little CPU required to build a new virtual machine as opposed to what we see in Composer. Composer generates a lot of work on vSphere, a lot of I/O. It's very modest I/O to fork a new VM, and it solves that peak memory problem through the use of pages that are already shared in memory through transparent page sharing.
So if you're thinking about buying your servers, instead of having to cater to peak conditions, you might actually be able to provision less physical RAM, because you know that when you build a pool, there's no more memory storm. So you start out sharing everything, and you just gradually grow toward your sort of average rate. So maybe you can buy less.
Potentially, or you can redeploy that memory where you need it. perhaps to applications and things like that. That gives us the greatest operational flexibility, greater than ever before. You can upgrade your base image and applications without maintenance windows. You might still, of course, I think, there's still an agreement between IT and the user community. We don't want to just become mavericks and cowboys overnight. However, the maintenance windows can be measured in minutes instead of hours, or sometimes entire weekends. I think this is really impactful for IT and for our line of business customers. But occasionally, you might want to do a change right at the moment. If there's a malware breakout, or there's a critical bug that needs to be fixed in your business critical application. And you can deploy these new applications without forcing users to log out.
Exactly.
Although, if that's what your operational model is, we still conform with it. We don't necessarily break it, do we, Daniel?
No, yeah, exactly. But you can even deploy an upgraded application. When the user closes it, the next time they open it, it'll go to the next version.
Right. But sometimes users could be disoriented if the deltas are a little too wide between closing an app, reopening it, now it looks completely different.
Sure, exactly. So let me talk about zero-copy architecture. I mentioned this earlier in the presentation. Zero-copy architecture is sort of the underpinning of this new just-in-time desktop. It's an architectural idea where you represent information, sort of think of it as a holograph up in the VM without actually copying bits around. Zero-copy architecture, the goal is really to create a valid desktop. The operating system thinks it has all of its own memory pages. In fact, it doesn't. They're just pointers. It thinks it's got its own copy of that application. In fact, it doesn't. It's just represented in using the Cloud Volumes sort of filter driver. So instead of copying things around like you would do in the physical world and just doing that in the data center, we're taking a new approach. We're virtualizing that work, and we're creating zero-copy architecture. And that's why we get the speed, because we're not actually doing any work. We're not just trying to do it faster with wider pipes. We're just getting rid of it and saying, let's semantically represent that desktop and only pay the price of transfers in the data center at the point of consumption, which is always the cheapest cost. So zero-copy architecture is a sort of a big idea, and the just-in-time desktop is the result of that big idea.
Absolutely. So let's take a minute and talk about Project Meteor. Project Meteor is an internal VMware project name for launching a new just-in-time desktop paradigm. Now, you might have seen some crazy VMware project names over the years. The reason for those names is that we want to come up with something that's completely irrelevant so that we could save cool names for trademark purposes later. So what we do, and it's true, I don't tell the truth all the time. I'm in marketing. But what we're trying to do here is we're bringing Project Fargo, which is the rapid VM forking, to Cloud Volumes and creating these two initiatives together. Project Fargo is the hot cloning of a virtual machine from a live template in seconds. Cloud Volumes allows us to inject IT applications and have user-installed applications and profile follow those users wherever they go. And the result is a fully provisioned and customized desktop built on the fly during login in under 5 seconds. This is really a provisioning paradigm shift. VMware is disrupting the status quo for VDI provisioning and for ongoing maintenance. Our thought process here is to try to inspire desktops. It's the desktops inspired by mobility.
Wait, go back there for a minute, John.
Oh.
You know why they called it Project Meteor, don't you?
I don't know why they called it Project Meteor.
Well, I heard the inside scoop is that Meteor's headed right for our competitors. That's what I heard.
That's amazing.
Yeah,
it's really cool. How did you manage to get a picture of it?
Well, we'll talk about it later.
Oh, very good. Okay. All right, so what does desktops reimagined inspired by mobility really mean? Okay, well, let's take a look at it for a second. Up here in the cloud, you've got your applications, storage, and we've got automation and VMware magic up in there. And then we've got the kinds of devices that users want to use, and in fact, will be using in the not-too-distant future. Of course, there's still PCs and thin clients. There's laptops and tablets and smartphones, and pretty soon, everyone will have a Tesla. Don't you agree?
I think so.
And has anyone been in a Tesla? There's something that looks like an iPad on steroids. It's this really cool user interface. Very cool stuff. What color is your Tesla, sir? Oh, mine's blue, at least in my mind anyway. It's blue. All right, so what does this look like? We start as the administrator by creating the live template. And so we talked about how that's done, and that runs on vSphere, and now it's in that suspended state. But I emerge from my Tesla, and I take out my iPad, and it's time to launch an application.
So that's a purple zombie.
That's the purple zone. So here I am in the purple zone, launching my desktop from my iPad. Now,
purple zombie.
It's a purple zombie.
Yeah.
All right, very good. And so now behind the scenes, a zombie is forked, and we produce a green clone. And so this is the operation behind the scenes where the desktop is being created just in time. And what that means is we've cloned the VM, we've dynamically injected the applications, we've persisted the user data, and lo and behold, before long, we've actually got a desktop to serve up to that tablet. And what happens when that user session is done? We persist the user data, we persist the data that's been written, we destroy everything else. Exactly. And we persist it on vSAN. So really what we think we're doing here is we're simplifying VDI. We're bringing it all together. There's no more catch-22 type planning here. VDI 1.0 was a choice, and a very difficult choice, choosing between persistent and non-persistent designs. Persistent is more flexible, but it's very, very costly. Non-persistent is lower cost, but it can't accommodate all use cases, and that was a really bad trade-off. In some cases, we had environments that had both. Very difficult to manage. We got that image diversity sprawl issue that we talked about. With VDI next generation, almost all users can be accommodated. Wouldn't you agree with that?
Absolutely. In fact, you could even have one large pool that accommodates knowledge workers, power workers,
power washers,
and also task workers. So without separate pools.
Of course. I mean, who would want their own pool?
Unless you're in Florida.
Unless you're in Florida, and then they're essential. They come with the house. And so this is VDI simplified. VDI simplified is one large pool based on a common base image. And this is something we've been talking about for a really, really long time. So why don't we take a minute and talk about how we bring this by leading with hardware.
Sure. Well, we've got, these are the sort of the key solution elements we've talked through. Just summarizing, we've got advanced layering, rapid provisioning with Project Fargo. We've got advanced vSAN design so that your persistence layer is on the most advanced flash stuff that's coming down the road. vSAN will support that. It will give you a great user experience. But we also want to persist less than we did before. Think about that. Keep one copy where it's appropriate, 2 copies where you need to.
I like it.
Of course, Project Meteor bringing together that super rapid provisioning that's never before been possible. This is a great story that comes from a powerful set of new features in the vSphere platform. And lastly, we've got the simplified design paradigm. From a consultancy standpoint, when you come into the customer can make more simplified choices. We just want to give our users desktops. We don't want to just tell you how to make them efficient. We just want to deploy them, and it's VMware's problem to make them efficient.
No regret VDI.
No regret. Just give us an efficient desktop. Don't make us make awkward choices. So that's what we're going to deliver on in this next generation of VDI. We're going to also have this new design shift where instead of baking data into VMs and into VMDKs, we're going to use them more as scratch space, execution space, and there's going to be a reference copy up in the cloud, whether it's the Windows profile, the file sync for your documents, or even these cloud volumes-based applications. We're going to be able to reassemble your desktop rapidly from assets that are stored and abstracted outside your desktop. So from a DR standpoint, we can do DR more efficiently. We can reinstantiate your VM over at a different data center using assets that we replicate in advance. So it's going to make DR easier. It's going to make provisioning much easier. So we've talked about the ways in which vSAN supports this vision. The object-based policies mirroring more intelligently in tandem with layering to achieve that state separation.
Low cost, high performance.
Exactly.
So, you know, I suppose for all of you, there's a couple of key takeaways that we'd really like you to leave with today. First of all, we believe that next-gen VDI is disruptive, meaning that we've disrupted our own vision, which was VDI 1.0, which, by the way, incidentally, is still pretty popular out there. So we think that this is sort of like just-in-time disruption. The way that we're doing that is by delivering simplicity, performance, flexibility, and at low cost. We're doing this just in time in a way that brings the most flexibility to you as customers and to you as IT administrators, and I think to VMware in a very disruptive way. So we are right on the money here in terms of time. Daniel and I always like to entertain a few questions. What we're going to do is we're going to entertain questions 4 blocks away, if you can catch us. Actually, no, we'll be standing right outside. Just give us a second. We'll clear the room. We'll meet you outside. Thank you very much for attending VMworld 2014. Thank you.